in this lesson we'll be talking about a negative or capsule stain. So we typically do negative staining for one of two reasons. Either a bacterium cannot be heat fixed. So if you're a lot of times working with bacteria that have maybe a sporellum or a spirochete type shape, which are like loose waves or spiral, if you go through the heat fixation process with them while you're doing smear prep, what can happen is it can cause them to shrivel up into a little ball and look more coccus in shape, whereas they should have been like an elongated spirochete or sporellum. So typically with those types of bacteria that would kind of suffer the effects of shape changes during heat fixation, we would opt to do a negative staining procedure on those because negative staining does not require heat fixation. Another reason why we would do a negative stain is if we're trying to stain part of a bacterial cell that does not readily absorb stain. So this is often done when we're trying to stain bacterial capsules. Capsules are like an outer protective layer that surrounds the bacteria, so they're going to be resistant to absorbing any type of toxic chemicals, of which stain would fit into that category. So since we can't stain the capsule, what we do is we do a negative staining procedure where we stain the background behind the capsule and then the capsule sticking out against that dark background. So those are the reasons that we would choose to do a negative stain. I will say simple stains are definitely more common. So in our labs we will typically choose to do a simple stain where we stain the bacteria. But if you do meet one of these special circumstances, then you would do a negative stain. So in a negative stain, it's kind of the reverse of what we talked about with the simple stain. So in a simple stain, your intention is to use a basic dye that will bind to the bacteria because it was positive charge. It will bind to the negatively charged bacteria and stain the bacteria color, purple, blue, pink, whatever it be. When you're doing a negative stain, you're doing the reverse of that. So in a negative stain, you actually need an acidic dye. And acidic dyes have a negative charge. And we know that bacterial cells also have a negative charge. And if you remember from previous courses, like charges are going to repel each other. So when you use an acidic dye, you cannot stain a bacterial cell because of that repulsion. Instead, what you will do is you will stain the background behind the cells. So the background will be dark, and then the cells will be clear, sticking out against that dark background. So in this example, an acidic dye called nigrosin was used, which has stained the background this black color, and then the bacterial cells that were resistant to the stain because of the negative charge repulsion are clear against that dark background. So it's a different way of doing things, but you're still creating that contrast so that you can see the specimen. In the simple stain, you are staining the cells so that you have dark cells against a white background. You have that contrast though to see the cells. In a negative stain, you're staining the background and you'll have clear cells, but it still, again, creates that contrast so that you can see the bacterial cells, like shape and arrangement. I always kind of think of it as stars in the night sky, whereas the night sky would be the acidic stain that you've chosen, which this is nigrosin. There's also a pinkish reddish one called eosin. And then the stars sticking out of that night sky, or the stain, would be the bacterial cells. So to do a negative stain, remember it's going to be different from a simple stain because it does not require heat fixation, which is something important to remember. Simple staining, you do have to heat fix, but in negative staining, you do not heat fix. So what we would do is we would just add a drop of the acidic dye to the either end of the microscope slide. This one's nigrosin. And then you're going to add a sample of bacteria directly into that drop of stain. And then you're going to spread that drop of stain using another slide throughout the rest of the slide. And then you are just going to let it air dry. So it's a pretty simple procedure. You'll let it air dry, and then you'll put it under the microscope all the way up through oil immersion, and then this is what you would see under the microscope. And again, the background is going to be stained. I know nigrosin stains black, but it always looks more like a light gray. But the background is going to be stained. The cells would have resisted the stain because of the negative charge repulsion, and they're going to be clear, sticking out against that background. But again, because we've created contrast, we can see things like shape and arrangement. So we definitely see some like streptobacilli in here, some diplobacilli, even see some single bacilli throughout the sample. Now, a negative staining procedure is often used to observe bacterial capsules. Again, bacterial capsules are resistant to stain. They're a protective layer that surrounds the bacterial cell, so they're not going to absorb stain. So since we know a capsule is not going to absorb stain, in order to visualize it and create contrast, we have to stain the background behind the capsule. So that was done here. So this stain was prepped using an acidic dye called eosin, which is pink. So the background is going to be pink, and then the capsules that were resistant to the stain, they're going to be these clear surroundings around the bacterial cells. Bacterial cells that have capsules are typically more pathogenic. Bacteria that have capsules are able to survive in the presence of phagocytic cells. It makes them pretty much resistant to phagocytosis, which is one of our body's primary defense against bacterial cells. If you remember from other courses, things like neutrophils and phagocytes, monocytes, they circulate throughout our body, and when they come in contact with a foreign pathogen like a bacteria, the macrophage would engulf and destroy the bacteria. But not if the bacteria has a capsule. Bacteria with capsules are resistant, so it allows them to survive in the presence of these phagocytic cells and continue to establish themselves within the host and cause an infection. So ideally, we want to know if a bacteria can form a capsule because it makes it more dangerous. And how we would know if a bacteria has a capsule or not is we would do a negative stain on the bacteria to observe its capsule, its clear capsule, sticking out against that dark background.